Hello. In this video, we're going to look at quadratic factoring, perfect square cases. Now, often students will memorize these and they will just simply apply the rule. If you can factor by decomposition or by inspection, you don't have to memorize this pattern. However, it's a good one to keep an eye out for because it will help you speed up your work. So let's just take a second and let's imagine I had x plus a squared. Well, we can all do this already. That's simply going to be x plus a times x plus a. And if I expand this, I get x squared plus ax plus ax plus a squared, which is x squared plus 2ax plus a squared. Okay, so now that I have that, I notice an interesting pattern here. Remember, a lot of math is looking for patterns and trying to figure out how to apply these patterns in interesting ways. If I have a here inside my binomial, remember binomial is a two-term expression, so that's a binomial there. It's a binomial squared. So I notice I have a squared here in a, and I have 2a for my b term, and there's a. So the question is, well, how can I apply this? Well, let's take a look. So if I have x squared plus 6x plus 9. The first thing I notice right away when I do this is that this is a perfect square. We want to keep an eye out for perfect squares. Perfect squares are really nice numbers because they often can give us hints as to what to do. So maybe I do a little rough work over here and I say, okay, the square root of 9 is 3. So therefore, 2 times 3 is equal to 6. And since this is 6, we see this is a perfect square case. So this factors to x plus 3 squared. And we're done. Let's do another case. X squared minus 8x plus 16. So again, the first thing I'm going to do here is I'm going to take a look at this. Oh, 16 is a perfect square. And then I'll come over here, do a little rough work. The square root of 16 is 4. But then I have minus 8. So I say, okay, well, the square root of 16 I could say negative 4 squared is 16. So therefore, I could say 2 times negative 4 is 8, negative 8. So therefore, if our b term's negative, we need to account for that by making the value inside our brackets here negative. So we have x minus 4 squared, and we're done. So often what happens then is the student asks me the question, okay, well, Mr. Miskew, this is great, but what about if I do this? That's an excellent question. And let's go through the same thinking here. So we're going to say bx plus a times bx plus a. We're going to expand this to get b squared x squared plus abx plus abx plus a squared equals bx squared plus 2abx. Well, I put minus there, plus a squared. And I see I have another pattern that emerges. Again, this first one and the second one are essentially the same concept, except for here the coefficient on the x is 1 and here the coefficient is b. So by looking at this more general case, what it allows me to do is deal with questions like this. 9x squared plus 12x plus 4. So if I was to do this question, I would look at it and say, oh, there's a perfect square and there's a perfect square. So that would give me pause. Say, okay, the square root of 4 is 2, and the square root of 9 is 3. So since the b term is 2ab, let's see, 2 times 2 times 3 is equal to 12. So therefore this factors to 3x plus 2 squared. And it's the same principle here as in the earlier case where if the b term is negative, we just have to account for that. So if I have something such as 36x squared minus, let's think of 16, let's say. So I'm making this up as I go, so please bear with me. 48, I believe. Let's see if I'm right. So if we had this question here, what I would do is I'd take the 16, and I'd say the square root of 16 is 4, and the square root of 36 is 6. Okay, so both of these are perfect squares, so I start thinking of my perfect square case, and I say 4 times 6 is equal to 24, and 24 times 2 is equal to 48. So I see my b term conforms to our pattern. So therefore this factors to 6x minus 4 squared. And we're done. So this is the perfect square case. Again, you don't have to memorize this, but it is useful in terms of speeding up your work. But if you know decomposition, all of these shouldn't be a problem regardless. Anyways, I hope this helped. Have a great day.